and share my screen, and let us begin with the topic for the Git. Now, first of all, what exactly is Git? That we will be seeing. Now, Git is a version control system. Git is a version control system. Essentially, what it allows us to do is that if we have our source code for our particular project, if we have the source code for our particular project and it consists of various folders and files, what Git will do, Git is the tool that we are going to be using to store that particular code. Now, why is that the case? Because Git is much more efficient and much more suited to these particular tasks. Okay, so version control system is allowing us to store various different versions of our projects in an efficient manner. So version control system is going to allow us to store the information regarding our projects, specifically the source code, in a much more efficient manner. Now, there are two different types of version control system that exist. So there are two different types of version control system that are actually existing. What are those two different types? So we have something called centralized version control system, and another one we have is distributed version control system. So we have two various types of version control system. We have centralized version control system and we have a distributed version control system. As the name suggests, for the centralized version control system, essentially we have a single central copy of our project on a self-hosted server. What do you mean by a self-hosted server? Is that in the machine or in the particular scenario or in the particular network where your company is working, there we have a single central copy of our project. We have a single central copy of our project, and then everyone, all of the other users that are present, let's say this is user 1, this is user 2, what they are doing, they are just committing their changes to this centralized copy or this central copy directly. So we pull or we gather. So when I'm saying committing, essentially what I'm trying to say or what I'm trying to explain is that I am pushing or I am letting my central copy know what changes I want to make. because as we will go ahead and develop more and more files, we will be adding more and more changes we will be making to our code. So what will happen, user 1 and user 2, basically they will be letting the central copy directly know this is the change that I want. And for that, what they are doing, only the files they will be needing, they will gather the files from the central copy first, only the essential files that they actually require, not the entire centralized copy, but rather only the singular files that the users require. So user 1 might require 3 out of 15 files for working. User 2 might require 4 out of 15 files. So they are not gathering all of the files on their system, rather they are simply taking few select files that they require, doing the development, and then going ahead and letting the central copy know that these are the changes that I want to make. Please go ahead and finalize those changes. Okay, so none of the users, they have a full copy of the particular project locally. So none of the users have a full copy of the centralized repository or the central copy. Locally, they do not have it present. Everything is present over here in the self-hosted agent in the organization. People just go ahead and gather the files they require, work on those files, and then let the server know again, okay, these are the changes that I've made. Please go ahead and finalize those changes. That is what happens in centralized version control system. What is an example of that? We have Apache Subversion. SVN is the shorthand that is used. Apache Subversion is a good example of what an example of a centralized version control system would be. But we are not going to be studying about Apache Subversion. Rather, we are going to be studying about Git, which is a part of distributed version control system. Git is an example of a distributed version control system. So example of that is Git. Now what happens in the distributed version control system? Let me show that. In the case of the distributed version control system, we are not relying on the central copy of the project. Right? We are not keeping a central server where all of our files are going to be stored. Rather, we have a copy present of our repository in the cloud. We have a copy present of our repository in the cloud, and whatever users are present, let's say we have 3 developers, they will gather all of the like the entire copy of the repository they will be gathering. So basically what they will be doing, they will be going ahead and fetching the entire copy of the repository locally, and they will be keeping it locally so that they can go ahead and have the full history of the project. What do we mean by history? By history, we mean whatever changes have been made. So there will be a long list of the history which will be including all of the changes that have been made. this entire history will be present for every single user because they are getting the entire copy on their end. They are locally copying, or you can say downloading, the entire repository or the entire source code structure that you are having. So your entire project is basically being copied over to each and every single user in the case of the distributed version control system. It is present in the cloud. From there, the people or the users that are present, they go ahead and fetch, or they go ahead and gather or download the entire copy of the repository on their end. Technically, in distributed version control system, we don't need to have this central location over here like the cloud, where we will be storing our copy of the repository, which will be our ultimate copy, which will be you can say the place from which where we will run the projects. But it is usually kept because that is a better way to go ahead and allow the people to collaborate. It is essential to keep a central location where we can store our entire source code, because that way the users that are present, or I'm sorry, not users, but rather developers that are present, they will be able to easily collaborate and work on the projects. Now, Git is an example of a distributed version control system. There are other examples as well. So we have something called Mercurial, we have Bitbucket, we have GitLab. There are lots of examples that are there, but usually Git and Mercurial are the ones that are given as examples. Most commonly for the distributed version control system. So Git and Mercurial are the examples that are given for the distributed version control system. So do you get this, everyone? What is centralized VCS? What is distributed VCS? And what exactly is going to be happening in each one of these particular, you can say, systems. Others also please confirm. I've only received the confirmation from Praveen that he is able to understand. Others also please do let me know. Just be a little interactive in the chat so that I can know that you are clear with this or not. Yes, Nilesh. Each user can use the entire copy of the project. It will be stored, like I said, it is not a rule in the case of distributed version control system to have it located in a centralized position, but it is usually the case where we have it centralized so as to avoid confusion, so as to have better collaboration. And users, what they do, or our developers, they get the entire copy of the repository or the folder structure of our project, and they fetch it or download it on their end, and then they begin their work. Now obviously you can think that in this particular situation centralized version control would be better, because in that case we are only getting what we need. But you can think of it this way, that in the distributed version control system, since we are getting the entire copy, we are downloading the entire copy, what it is allowing us to do is that we are eliminating any ambiguity that is present, because files are obviously going to be dependent on one another. So if you develop a new feature or if you develop a new file, there is a chance that your entire project is going to break because of that. So it is better for it to break on your system rather than on the centralized copy. What if multiple? Exactly. See, Ashwani, what you are mentioning, that is actually a concept in Git. That is a concept called merge conflict. Like I said, there are issues that are present that are very obvious, but regardless, this is the best solution that we have at the moment. Distributed version control system. Hence why it is used. Obviously, it has problems, and we will be discussing those particular problems as well. So, merge conflict, it is exactly what you have mentioned. If two developers or three developers are working on the same file and they push, I'm sorry, not push, but rather let's say they have downloaded it, they have made the changes, then they upload the particular files one after another. How will Git get to know that which particular file it should keep? That situation is called as merge conflict. Now we will be discussing it once we have actually covered some of the topics, because before that there's no point in discussing, you will not be able to understand it. Till here, I hope everyone is clear, so let us go ahead and begin with the next task. Let's go ahead and have a look at the next point. Now we will be going ahead and moving directly into Git, because we have now seen the you can say hierarchy, that what exactly is Git. Git is a version control system, specifically an example of a distributed version control system. So now we can go ahead and start with the concepts specifically of the Git. So now when we are talking about Git, when we are talking about Git, there is a particular cloud repository, or I'm sorry, cloud storage, you can say, where we are going to be keeping the central copy or the final copy of our particular source code. That is called as GitHub. It is a website that is present where we can do what? We can keep the finalized copy of our particular source code, so that if we want, we can collaborate with others, so that others can go ahead and also make changes to our code. So you can think of this as Google Drive specifically for source code. So cloud storage specifically for source code. Now, why specifically for source code? Because GitHub uses, I'm sorry, not GitHub, but Git uses something that is called delta encoding. Now, what that means is, when you are writing, let's say, a particular let's say this is your file 1. Where you have this as the entire file. So this is your entire file's contents. File 1 contains A, B, C, D, E, F. 6 lines it contains, each containing the first 6 words of the alphabet, first 6 alphabets. Now, if we go ahead and make some changes to our file, let's say, if we make some changes to our files, file 2, where we mention what is that A, B, C, D, E, F is fine, but I want to add something G, H at the end. In the case of Git, what it will do is that it is not going to be storing the entire file again. So this is the first, you can say, instance or first existence of this particular file 1, and you make changes to that same file 1, and what you say, you add 2 particular characters there. Now what Git will do, Git will not go ahead and save the entire file again. It is not going to go ahead and save the entire file again. Rather, whatever changes you have made, that Git will go ahead and store. So this is the first, you can say, iteration, or the first time your file 1 has shown up. What Git will do is, Git will not go ahead and edit the file 1. Git will not go ahead and create a new instance. That is what I'm saying, Prabhakaran. It will not save the entire version. It will just save the changes that you have made. So it will save file 1 plus G and H. So simply the changes that you have made, that Git will be storing. It will not store the entire file again, because that would take up a lot of space. So only the essential changes that you have made, that Git will be storing. Whatever remains the same, Git will go ahead and ignore that. Similarly, let's say you have your file 3, which is your third iteration of your particular file. Third iteration of your file. Here what you decide to do, you decide to remove the D over there. You remove the D. So in that case, what Git will do is, Git will not go ahead and save the entire version of the third file. Instead, Git will just say over there -D. So Git will say that file 1, whatever was stored in the beginning, -D. So only the particular section that you have removed, Git will go ahead and save that you have removed this particular character, this particular word, this particular sentence. That is what Git will be storing. Now remember, if you delete a file, regardless, that file is still going to be stored. Even if you delete the file, it is going to be stored, because earlier on you have created the file. So hence what it will do is that if you delete the entire file in the next iteration, it will simply be that F1, that is present the file 1, minus the entire file you are deleting. So even if you delete the file, the first iteration of the file or the last iteration of the file which actually existed, information till that will be stored. So it is having the entire history as to what changes you have made to the particular file, and that will be the case for your entire project repository or for your entire project folder, not just your particular, you can say, files that are present or particular source code, but rather your entire project's entire history is going to be stored. So delta encoding, which simply means that only the changes that you are making, that is being stored. Okay. Raghunath Reddy, you can delete. I'm not saying that you cannot delete. You can go ahead and delete the file, but information on the file that actually existed, that will be stored as history. So if you made changes to this particular file for three particular versions, 3 times you made changes to the file, all of those changes that you made, that will be stored. If you add anything by mistake, you can edit it, right? You can edit and correct it, but the mistake that you have made, that is also going to be stored. The mistake that you have made, that will be stored as an earlier version of the file. Yes, exactly, Ashwani. So time is going to be mentioned, by whom the changes have been mentioned, by whom the changes have been created. If there are multiple people, right, all of that information is going to be stored, and obviously the changes as well that you have made, that is also going to be stored. So the entire history of your entire project is going to be stored. Even if you have made some changes by mistake, it does not matter. Git is going to be storing those changes. Git will have the history for those particular changes. So let us move on to the next point. So in the case of Git, we will have two particular situations here. The users that are working, let's say user 1 and user 2 in this case, on their local machines, they are going to be having Git. On their local machines, they are going to be having Git, and they are going to be using Git only to go ahead and make the changes to the particular copies of the repository that they will be fetching or downloading. And where these particular files will be present, they will be present in GitHub. So your copy of your repository will be present in GitHub, and from there your users or your you can say developers, they will be downloading it on their systems. So in GitHub you will have the copy of your project folder, and then in your specific developers, in their machines, they are going to be having Git downloaded, which will allow them to make the particular changes in the particular Git project folder that you will have created. Okay. Now, what is the terminology that is used to refer to these particular project folders? They are referred to as repositories. So these project folders that we are talking about, they are referred to in terms of Git as repositories, which uh, will be essentially the source code that you have created. So the entire folder structure for your project will be referred to as a repository or repo for short. Repository or repo for short. Okay. Now, when you are going ahead and copying the repository or downloading the repository on your end, it will be downloaded in the with the exact history that is present in the repository at the moment. So let's say that this is our structure or timeline, let's say, of changes that have been made. At this point of time, user 1 decides to go ahead and fetch the code on his system. And at this point of time, user 2 goes ahead and decides to fetch the code on his system. So at this point of time, whatever is the history that is present for the particular project, user 1 will be getting the entire history or the entire information about that. Now, after that, if any new changes have been made or decided upon, user 1 will not go ahead and have them available on his system, but user 2 will, whatever in this particular duration, whatever anyone has gone ahead and made any absolute changes, those particular changes user 2 will be getting, but not user 1. Right? It is obvious that user 1 has downloaded the folder at an earlier stage, so he will not have the particular updates that were introduced later on. This process of uploading and downloading that I'm referring to, what is it referred to in technical terms? Let us see that. So this uploading, that is what I'm talking about, is called as push or pushing, and this downloading is referred to pull or pulling. So when we say I am uploading the file, that means I am uploading the changes that I have made. I am pushing the changes that I have made. So I download a file, I download my source code, I download the copy of my repository over here on my system. I pull the particular code. Okay, that will be the technical term. I pull the code on my system. I make the appropriate changes. And then what I do? Then I upload that file over there to the repository, the GitHub repository. So I push the changes to my GitHub repository. So downloading is just pulling, uploading is pushing. So these are the technical terms that I used in order to decide on the changes that have been made. So pulling means downloading, pushing means uploading. Now, the stages that will be or involved in the particular Git life cycle, that is what we will be discussing next. But before that, till here, please let me know if everyone is clear with this or not. Okay, great. So we are about the halfway point right now. So I'll create a poll to get an input from you guys regarding the duration of the break. Just let me know what amount of time you want for the break. If you don't want a break, I've included that option as well. You can go ahead and let me know your thoughts over there. Accordingly only, we'll go ahead and have the break. The next topic what we will be discussing what exactly is the life cycle for the Git. Okay, so I'm ending the poll now. 65% of the people present in the session have participated in the poll, and among them 52% have mentioned for a 10-minute break, 38% for a 15-minute break, and 5% each for 20 minutes and no break. So in that case, we'll have a 10-minute break, and once we get back, we'll go ahead and continue on with the next concept, which will be the life cycle. So let me set up the timer, and we'll be having the 10-minute break now. Okay, so the break is over. I hope everyone is back from the break. Please let me know in the chat. Okay, let's go ahead and now continue on with the next task, which was the get life cycle. Now, these are the commands that will be used as part of the life cycle. So the first command is going to be get init. Now all the commands are going to be in the shorthand or in the lowercase. These are going to be the commands. So get init, get add, get commit, and finally get push. So, or rather than get init, we can use another command called get clone. So now what are these commands trying to signify? Let me tell you. The first command that we are seeing over here, that is get init. So when we are going ahead and starting off, we're just creating a simple folder, and that is all there is to it at the moment. It is just a simple folder. It has nothing uncommon in it. In order to allow Git to work inside this particular folder, or in order to make sure that this folder is registered as a Git repository, in order to make it so that this particular folder is recognized as a Git repository, what we have to do, we have to use the init command for that. So what does the init command do? The init command initializes an empty Git repository. So Git init, what it does, it initializes an empty Git repository. So Git init initializes an empty Git repository. So the repository that will be created, that is not going to be containing anything at all. So it is going to be totally empty. All that will be present inside will be like, even if you have created files previously, they will be present, but Git is not going to be recognizing any of those particular files. So even if files and folders you have created inside that folder that we have just now created a repository out of, Git is not going to be considering any of those files as part of our next two commands in conjunction, which are add and commit. So these commands are usually going to be used together. They're not going to be used only one at a time. Both add and commit. Sure, Raghunath. So what I'm saying is that when we initialize the repository, it is empty, which means that even if there are files that were present over there inside the particular folder, they are not going to be considered as part of my repository, which means that they are not going to be considered as source code that I want to be part of the repository. If I want them to be included in my repository, I have to use these two commands in conjunction. So add and commit. So first add and then commit. I cannot use only one of these commands. I have to use both of them on the file that I want to go ahead and you can say include as part of my repository. So that goes for folder or file, not just file, but rather folder or file. Any folder or file I want to include into my repository, I have to run both the add and the commit command one by one in order to make that happen. Okay, so what does the add and what does the commit command do? Let us go ahead and check that. So add command, what it does is that let's say there is a file. So how exactly things happen is that in your repository, let's say you have one particular file present. So what will happen with this particular file is that Git, even though Git knows that this particular file exists, Git cannot go ahead and start tracking the changes for each and every single file present. So Git cannot go ahead and keep the track of every single file in your system that is going ahead and having the changes made. That is not possible. We have to define which particular files we want Git to track. So we have to let Git know this particular file I want you to track. And when we are talking about tracking, we are meaning that I want you or I want Git to keep a track or to keep a note of this particular file for later. Right. So there are two main stages over here, or two main areas I would say, that are going to be considered in this scenario. So this is before even during as well it works. So these are the two areas that usually exist. So we have the staging area, or we have staged files, and we have unstaged files. These are the two types of files that will be present. So when we say staged, that means the git add command has been run on the particular file. When we say staged, that means the git add command has been run on that particular file. When we say unstaged, that means the git add command has not been run on that particular file. So when we run the git add command on a particular file, what that means or what that does is Git now starts to keep track of the changes made in that particular file. But it is not finalized as of yet. Everything is not finalized. Now Git only knows that okay, this is supposed to be part of my repository. Okay, so that means it will be staged or it will be in the staging area. It is not yet part of my repository. It is simply in the staging area as of right now. Okay, so git init will initialize the empty repository. It will not contain any files or folders as of yet. When I run the git add command, then the file, so git add followed by the name of the file that I want to add into the staging area or the file that I want to stage. What that will do, that will go ahead and let Git know that this file should be part of my repository. It is not yet part of my repository. So git add is not the final command. It is just the first command in the two-step process that is present. So git add will simply go ahead and let Git know that this file is supposed to be part of my repository. So please go ahead and move him to the staging area so that I can then go ahead and run the commit command. So when I will say commit or when I will run the git commit command, what will happen is all the files present in the staging area or all of the files that have been staged will be committed. So it's not just one file, right, that you're going to be staging, because if you are creating a source code, you will have multiple files present, multiple files, multiple folders, multiple subfolders present. So what you will be doing, you will be staging all of the files that you think are going to be part of your repository. And once you have done so, you will go ahead and commit all of the files in the staging area or all of the files that you have staged. You cannot go ahead and select files from the staging area that you want to commit. You cannot do that. You cannot select files from the staging area to commit. All the files in the staging area are going to be committed. And committed means it is part of your repository. So once the commit command is run, that means all of the files that you have just now committed are finalized as part of your repository. So there are going to be multiple files present in the staging area that you have run the git add command on. All those files will be committed once you run the git commit command. So remember, you can select which files you want to move to the staging area or you can select which files you want to run the git add command on, but you cannot select which files you are going to be committing from the staging area. So from your uh, like repository, I'm sorry, not repository, but rather your directory or your folder, if you have 10 files, you can choose from those 10 files which particular files you want to move to the staging area, or which particular files you want to run the git add command on. Let's say the number is 8. But next point that will be present, which will be commit, there you cannot go ahead and choose that among these 8 files, only 5 I want to commit. That is not possible. You can choose which files you want to stage, but you cannot choose which files you are going to be committing. All the files present in the staging area are going to be committed once you will run the command, the appropriate command for the commit. Now, obviously, the commands we will be checking a bit later on. Today, I will be showing you the installation procedure that you guys will need to follow. So I'll just let you know about the procedure, and then later on you can go ahead and complete the installation, so that tomorrow you can also do the hands-on that I will be doing alongside me. So hands-on of the specific commands. So now unstaged means the files are not staged as of yet, which means that they are just existing. They are not part of my repository. Git does not know about them. They are just existing. Staged means that I've taken the first step towards committing those files. I've taken the first step towards the commit, and I have told Git that these and these are the files that I think would be worth committing. And next, with the git commit command, I finalize the procedure and I let Git know that these are the files I want you to commit. These were in the staging area. Commit all of them. They are part of my repository. Okay. So that is what git commit will do. And finally, git push. That command is used to upload the files to my remote repository. Remote repository and local repository are two terms that are going to be used. When we are talking about a GitHub repository, that is referred to as a remote repository. And when we are talking about a Git repository, that is referred to as a local repository. What this means is that what I have present in my cloud, that I'm going to be calling as the remote repository. Because the one that is present in GitHub, even though I have access to it, I'm not storing it in my system. I'm storing it in the cloud. So that is called remote repository because it is located remotely. It is not located with me locally. The one that I have locally on my system, that is called local repository, which is the Git repository. So the Git repository, which means that the one that I have available on my system, that is called or referred to as local repository. The one that I have uploaded in the cloud in the GitHub, that is referred to as remote repository. So git push, what it does, it essentially uploads the file from the local to where? To the remote. So from local to the remote, the files are pushed, that is, the files are uploaded. So from my local repository, I upload the files to my remote repository so that I can store them in the cloud. So please let me know if you are clear with this, what we have discussed over here right now or not. Till here, if you are clear or not, let me know in the chat. Okay. So what commands I have shown? I have shown get init, add, commit, push. I've just given you the insights for these commands. Now, obviously, practical, like what these commands are doing or performing it over there, I'll show tomorrow. Before that, you will also have to install the particular Git on your end. So Git and GitHub account creation also you will have to do on your end. So one more thing that is left over here, the command that I have written, that is git clone, and in addition to that, git pull. These two commands I will show. Then we will have a look at the GitHub account creation and the GitHub installation. I'll just give you the quick steps to that, and you can go ahead and do that on your end. So the commands that we will be seeing next are two commands. Git pull and git clone. So like I have told you guys earlier as well. So they can just like when I'm explaining the things, just have a look at it, right? I'll let you know. Like I said, let's discuss these two commands, then we'll move on to the installation. I'll give you the steps. Please just pay attention over here first when I'm explaining the things. So like I have told you earlier, pull refers to downloading, push refers to uploading. So push is for uploading, pull is for downloading. Now push and pull are for specific changes that you would like to push or pull. So you would like to upload or download. Push and pull are for specific changes that you would like to upload or download. Usually when I want to download my entire repository structure or my entire folder structure for my project, I will use the command git clone. So what git clone will do is that there is a concept in the you can say Git called branching. So there are branches in Git that are present. Push and pull are used for specific branches. We'll see branches tomorrow, not right now, because before that you need to check the hands-on or the commands I will have to run first of all for these repositories that for these commands that I have shown you guys. Then we can move on to branches, not before that. But just know this, that there is a concept called branches in repositories, right? In my repository, I can have multiple branches present. Push and pull are branch specific. So if you want to upload or download a specific branch, then we will be using these commands. Push and pull we will be using if we want to upload or to download a specific branch. Whereas git clone, what it will do, it works on the entire repository. So git clone will download the entire repository structure on my machine. So git push and git pull work for uploading or downloading specific branches in my repository, whereas git clone downloads the entire content of the repository. Okay, so what branches are? Don't worry about that just yet. We'll see that later on. So please let me know everyone if you understand what they are supposed to do or not. Like the scope of push and pull is limited, whereas this scope of git clone, that is a bit bigger. So git clone works on the entire repository. Git push and pull work for a specific branch of the repository. You can think of the branch as a specific section. So if this is your repository and you have 4 branches, and say that each of these branches are occupying a position, so you can use git push or git pull on one of these branches or on all of these branches. So git push and git pull are branch specific. So you will have to specify which branch you want to use it for, whereas git clone works on the entire repository. So let me know everyone, are you clear with the overall idea of this or not? Just let me know in the chat. You mean on your local machine, Raghunath? Yes, you can do that. It is like simply copying what you are saying. You want to make a copy of this folder structure. Obviously, you can just right click on it, click on copy, go to the desired location, click on paste. That will be copy pasting. That will be creating the copy of the repository. But if you're talking that if there is any specific command called get copy, no, there is no such command. There is no such command in Git to copy or paste the repositories. But if you want to copy and paste the repositories, it is simply like copying and pasting. So Control C, Control V. But there is no specific command called get copy or any command that allows you to copy. No, there is no such command. I think the maximum size is 100 MBs. GitHub is designed for source code storage. Source code is usually small. So It's about like even if you're writing code, max to max, it is going to be 10 MBs a file. That is if you have written a lot of stuff. Usually the size of the files when you're writing source code is small. Okay, so I think the maximum size is 100 MBs. That is specifically for the free version, I believe. Yeah, if your data set also, I believe, what would be the maximum size for your data set? I don't think that is going to go in the gigabytes. It's also going to be about around 100 MBs max, 100 to 100 MBs max. It is going to be, right? What would be the maximum size of the data set that you have used? In that case, you will have to keep the data set separate. You cannot upload it to the GitHub. What I'm saying that 100 MBs, that is for the free version. For the enterprise edition, there is no limitation. When you will be working in a company, obviously you will have the enterprise edition. So for your own personal account, you will not be able to go ahead and upload it to GitHub. So you will have to keep it separate. Let me know everyone if you are clear with this till here or not. Okay. So now the next point is going to be specifically for the GitHub and for the Git. So for GitHub, you can simply go to this particular URL www.github.com, and there you will be able to create the account. You can just click on sign up, and here it will ask you for the relevant information. So your username, your email ID, all of that information will be asked. I have a reference document available on my end specifically for creating the GitHub account. I'll share that with you guys over the chat. You should be able to follow it in order to create the account on your end. Let me show the document. So this is the document that we have available for the account creation. You can follow this particular account for creating the, you can follow this particular document for creating the account on your end. So it asks simply for your email ID, password, username, and that's it. It sends you a verification code to your email ID, and after that it is successfully created. Okay, so let me share this one with you guys over the chat. I've sent the document in the chat. You can go ahead and download it on your end, and you can create the account later on. Let me know if you're able to download it or not. Just let me know over the chat if you're able to download the file that I've shared in the chat or not. Okay. Now specifically when we are going to be working with the Git, we will be using this particular tool. This is the official website for Git, and here we will be able to see the downloads option over here as well. So downloads, and if we go there, we will have the option for both Mac and Windows and Linux as well if anyone is using. So Mac, Windows and Linux, for all three, you have the options available over here directly. So we simply click on the particular link in order to download the setup, and then we will have to simply just go ahead and click on next in order to install it successfully. In my end, it is already installed. Let me just check it once. Yes, it is already installed on my end. Let me just uninstall it and I will install it again. Yeah, I have uninstalled it. So basically what we will have to do, we will have to go to the particular operating system that we are using and download the executable file. Now if you are using a Mac, you can go ahead and click on the Mac option to get the document, the file in order to install it on Mac. Okay, Sujaykant, you can find the option for Mac as well, so you can download and install it in Mac as well. So just click on Windows, and since I'm using Windows, download the install installer for it, and once it is downloaded successfully, we just open the particular file, or rather the executable, and then we just have to click on next. No changes are supposed to be made, just keep clicking next and that will be enough. Raghunath, it will depend on your system. Just check over there system information, just search. Just search for system information in your Windows search bar and open it. There you will be able to see whether your system type is 64 or 32-bit. Depending on that, you will have to download the appropriate file. All we will have to do over here is just keep clicking on next. No changes are supposed to be made. Here you can choose this option to create the you can say uh, shortcut on the desktop. That is optional. Keep clicking on next. No changes are supposed to be made whatsoever. Just keep it as it is. Keep clicking next and install. This will install the Git over there successfully in your system, and you will be able to use it on your end. So with this, Git is successfully installed in my machine, which means I can click on finish to complete the installation procedure. So with that, the installation is complete and Git is now installed in my particular machine. If I want to access it, what I'll have to do, I'll have to search for Git bash in my particular search bar and then open that particular application. Git bash and then open the application in order to access Git. Okay. So everyone, please go ahead and install the Git on your end as well. And after this is done, you can go ahead and create the account for GitHub on your end as well, because you will need that. So please follow through with these particular steps for creating the account for the GitHub and for installing the Git on your end, because we will need it for tomorrow when we will be running these commands that we have seen over here today. So what commands we have seen today? Git clone, git push, git pull, git init, git add and git commit. So we'll be running these commands tomorrow. For that reason, I have shown the installation. So you guys also need to do the installation on your end so that you will also be able to run it actually on your particular system. So does anyone have any doubts regarding what we have discussed today? Please let me know in the chat. Others also, please let me know if you have any doubts regarding what we have discussed over here today. Okay, great. So I will ask you guys to do the installation on your end and be ready with it by tomorrow, because tomorrow we will be running the commands in the system, the commands that we have done today. Just do a revision of these particular commands on your end, and then we will go ahead and do the hands-on, like the practical of these particular commands starting tomorrow. And then we'll move on to the next concept, which will be branching. Okay, so since everyone is clear with what we have discussed today, I will wrap up the session now. Please install the Git on your end and also create the GitHub account so that we can use it for tomorrow. Okay, so thank you everyone for joining. I will be wrapping up the session now. In case you will have any issues while performing or understanding while doing the revision on your end,